Hello, everyone. I hope you can hear and see me correctly. Good. Let's actually start. So let's go with this one. Perfect. I see a lot of thumbs up in the chat. Great. We will get going. I will start sharing my screen. Feel free, if you have any input or urgent questions, to put them in the chat, either private or public. I will address most questions near the end. If anything is urgent, please put them up in the beginning. Great. You should be able to see my screen right now. So today's topic is about the complex job of energy management and how it's actually becoming more and more complex, and how can we mitigate this and actually make this work for everyone, because it also offers a lot of opportunities, and AI can be a big game changer in this. So let's dive right into it. I'm Joachim, one of the co-founders and CEO of Enercy. Background in climate science engineering in the past, so this is also where the spark came from to actually launch Enercy. So a bit of context. You're all energy managers, you probably know the majority of this, but buildings and facilities are responsible for 30% of the worldwide global energy footprint. It's an equivalent cost of 5 trillion euros in buildings. That is crazy. And in enterprises, I'm talking about enterprise companies only, 143 billion of that is lost in actually easy to avoid energy waste in large organizations. So it's a very big potential, and energy management, your job, is becoming more important than ever. But there's a lot of systems to manage this. More and more data, which is great, but you have to process them. Automation becomes complex. There's not enough people that actually are qualified to do this, as you will probably know. On top of that, we have more complex interactions with the grid and energy price volatilities, and then we have a lot of compliance and ESG requirements that only add more to that and are distracting from the core job of saving energy and saving energy costs and CO2. So let's start with a brief timeline. How did it actually evolve, and where does energy management come from? And some of you will have started their career maybe in the 90s or in the early 2000s. And the focus then was mainly on energy efficiency, cost cutting, building upgrades, more static electricity contracts, and grid capacity was not such a big problem. Electrification was also just getting started. Then renewables started to matter. We had PPAs, early PPAs coming up, solar and wind prices started to fall, but this also meant, in combination with more complex building management systems and HVAC, that the grid and the constant supply was not the case anymore, which has a lot of impact on how contracts are managed, how everything is now ran in practice. And this keeps on piling up. We, of course, way back in the 90s already, and scientists even way before, were talking about climate change, but actually serious net zero discussions and how to implement this and how to electrify things only really became concrete around 2015. But this also meant a lot of carbon reporting coming into play. EVs started to actually appear, and not like one or two cars as an example, but actually significant deployment in the market. And then we get more and more pressures coming on top of that. As you can see, 2020 to 25, storage starts developing, serious battery parks, dynamic and grid interactions, flex contracts, demand response becomes important, and this only will increase. You probably know this, or the majority of this. But the reality is this is a lot, and also the amount of bullets is growing the more we look to the right. We could even put more on this. Reality is your job is becoming complex, and your energy managers are superheroes in a sense in this space, but it's getting very hard to manage this all on your own. So now let's focus on a shortcut. How can we use AI as a sidekick for energy management teams? How can we improve your ability to grasp all of that and make sense of all of that at the same time with a limited amount of people in a team? Because there's only so many people that are really knowledgeable about energy management in the market. So very briefly, not going to dive too deep on this, but on how can you link different components of AI. And NRC, I think, is a great example of doing that, but this is how you can link components together to make sense of energy data and actually get an energy expert AI backing you. And there's some key components. It's not just about having data, but it's also about continuous data quality management, making sure your quality of the data going in to the AI is top-notch, and we can feed that back to the data collection. Then interpreting all energy data streams, all energy data, time series energy metering analysis, and then the power of generative AI. Everyone knows ChatGPT. Everyone knows the image generation that is possible. But what if you can train a system like that to know energy expert level knowledge and can combine that with analytics on metering data? If you can plug those two together, you have a really powerful machine. So this is a couple of examples, a couple of steps I want to focus on today where you can actually level up your energy management across the board. We can't dive deep in all of these, but these are some key points where a lot can be done. Step one is automating audits, knowing what is possible on any assets, because of what reason? Because it can win you a lot of energy efficiency, because it's necessary in function of grid net congestion, or because it's obligatory for some reason. That is the first thing, like knowing your patrimony and updating this knowledge base consistently. You can do this with AI. And then first going into quick wins. Then we'll go deeper. Like step 3 and 4 is when you want to go deeper, and step 5 is what's coming. Step 5 is what will become possible in the next few years, if everything is put together correctly. And then a big bonus win, and I won't focus on that today, but is also you can actually automate all of your CSRD, SECR, and similar reporting as well. So let's just automate that and put it away, and then we can actually focus on where we can make a real impact. So let's first start with step 1 and 2, and these are the fast wins. Where can we win on auditing, on making sense of our portfolio, having a good view on everything that's happening first, and actually act on the quick wins? So the first one is automated audits. So how can this be done with AI? First, we can actually build a generative AI, that actually can process millions of energy and facility related documents, course materials, books, feedback of users. All of this input, all super expert level materials can be digested if trained correctly. And if you combine it with teaching it how to respond factually on specific energy management issues, you get a very powerful version, let's say, of a ChatGPT, but that's specialized on energy management. The thing is, then you still have to have an expert that analyzes all of your data and can actually answer those and ask the right questions and interpret the answers. And that is the full key. And if let me go back to this one, that's where this type of AI engine comes into play. An analytics engine that actually interprets all your metering data and actually can ask the right questions automatically. And then it becomes super powerful. So what can come out of this? You can ditch all of the huge Excels and similar systems to make sense of all your full portfolio and what can happen and what is planned where. You have live audits continuously. And the most important one, you can ditch or avoid 90% of useless audits. And that doesn't mean that audits in person are not useful anymore, but we can replace them by focusing audits where they make the most impact and not just on every asset, which costs a lot and is actually a waste of time. I'm going to combine this then with step 2, and we'll then actually show you, give you a sneak peek at what this can look like. So step 2 is actually, and that is the first thing a lot of people somehow skip in energy management, but is actually automate the operational free wins. What comes out of these assets are sometimes actually things that cost very little to implement, very little to move forward with. And also on the other side, you have things that are anomalies appearing, things that break down, someone that puts a system to manual that should have been an automatic, a change that shouldn't have happened by a user. And that actually makes that you're consuming a lot more all of a sudden. If we can, from reacting ad hoc and trying to detect those with alarm settings that then give a lot of false alarms, can move away from that and move into automated, pre-prioritized pattern recognition of anomalies and structural problems that are quick wins to solve, and then translate these to root causes with this GenAI, Energy GenAI, you can actually automate that flow and dispatch those to technicians and use your existing resources, that's also where the free wins, to solve these anomalies and quick win structural problems. And this can, according to literature, save you approximately, on average, 16% in energy efficiency wins. So this is kind of a free win. This is something like a low-hanging fruit you should do anyway, because it's simple to do and at a very low cost. So let's now show a quick video of what this looks like on the first 2 steps of energy wins using AI. Here we start with an example organization with 16 buildings, 103,000 square meters. And as we see, we have the standard views, but what is key and what I want to focus on is the output of, well, as you can see, there's multiple components visible here, but let's dive into some of the automated audit features. So this comes specifically from requesting output. The AI, the first analytics layer, requests output to the generative AI layer we were talking about. That actually generates the specific issues or opportunities of winning, purely based on data. This is a digital building audit. So let's jump into an example here. This is an optimization of a ventilation system that comes out of it. And it specifically tells you, hey, this is what it would cost. It's a very cheap measure to implement. Will give you a very good payback period and good savings. And this is how we get to it. This is the methodology, how it's calculated, how the AI in the background gets to it. What benefits are, what subsidies are still available for this, what potential risks are, and what compliance reasons to do this are. It's indicated in blue is specifically things that are important for this one. So here is specifically the benefits on the peak load demands regarding net capacity, but also the fast payback on energy efficiency, and the subsidies available. Let's look into a different proposal, in this case for this building, a solar system. Where does this focus on? It is on, for example, compliance is really important in this case, and subsidies. Why compliance? The system knows that it will be obligatory to deploy this type of system on a building consuming more than 1 gigawatt hour a year, which is the case for this one. So this will be obligatory given the fact that there are still subsidies available today for this type of deployment. It is a good idea to deploy this right now. That is what this tells you and why it puts this one as one of the key priority features on this. So this is step 1, knowing what you can do where across the board. So regulatory and compliance oriented, energy efficiency oriented, grid capacity, and business risk oriented, and potential other reasons why it's a good idea to deploy these. That's step 1. So step 2 is about, okay, let's now prioritize these across the board for importance and actually execute these. And the first step in this is winning where the opportunities are free, where you can use existing resources, maintenance resources, existing team members to implement the quick wins and anomalies or installations. This typically can yield up to 16%, sometimes more. An example here, it will detect a lot of things, quick wins and anomalies, and then it will prioritize those that are the most important for you, so you don't have to run through all of the opportunities. This is an operational issue, for example, an anomaly. Let's click into it. It's on this installation. We have a metering, an issue on a ventilation meter. As we can see, this one costs more than 100 euros a day. Not the biggest one, but not negligible either. In less than 2 weeks, it costs, in about 2 weeks, or it costs this amount. And what you can see is that it detects the root cause behind this issue as well. And it says the input sensor for the ventilation units is faulty as the most likely reason. So as you can see here, you can actually set this to a certain, and dispatch this to a certain maintenance technician. And based on that, you can see the historical activity from when it was a new issue, and it's been posted to Dave. Dave has actually analyzed it, seen, hey, the frequency control is broken based on a broken CO2 sensor, and Dave then dispatched this to Carlos, and Carlos is actually replacing the CO2 sensor, which he did, which solved the issue. Good. Let's go to the next step. On this one, so now we go into the next 2 steps, and now it's okay. We inventorized everything and we live update that. We also now have the next step on, like, the quick wins are realized. We have put a process in place for that. Now what actually is possible is generating action plans according to your different drivers. And I know this is a diverse audience. You're all people into energy management, but some are more on an industrial level, others are in commercial buildings, others are maybe in hospitals. Each one of you has to manage all drivers for energy management, but some will be more important for some of you than others. And that is also key, that you can see all of the opportunities from efficiency to grid related, demand response related, across the board, but can prioritize those in function of what driver is more important for you than another one. And some key drivers are typically the classic one, energy cost, of course, limiting CO2 emissions net zero, but also ensure supply, limit business risks around net congestion, and also regulatory compliance, of course, make sure you implement what is obligatory. And that will be the guideline behind step 3 and 4. So the first one is, how can we actually make an optimal plan, but without building huge Excel files and like doing this once and then forgetting the plan and implementing something else afterwards, which takes months and months of time to build, and you don't want to do that every time. What if you could generate an optimal plan automatically and then tweak it with your business knowledge and keep that as like a live document? And this can be done with AI. And step 4 is not only just generating it, because that's great if you generate and tweak a plan, but ensure that it's actually executed as planned or changed if the execution doesn't go as planned, and you live update an in-sync deployment with a plan. And that is actually what a lot of people, like you, will actually know. You have the PDCA cycle, which is core at the, by now, 30-year-old ISO 50001 standard in the end, or at least the data behind it. The plan, do, check, act cycle, where you actually want to plan, execute, continuously check what works, and feed this back to tweaking your plan. The problem with this was that it took 4 years to do a full circle, and by then everyone forgot what they planned in the first place. And this wasn't working. But if you can do this live, see the impact of anything you do continuously, change your plan, and actually see your curve towards optimal energy consumption, optimal energy cost, and your CO2 emission target, it's a very different story. So we'll give you a quick sneak peek in how this can be done and driven towards these different drivers, which can be different for every organization. This is a combination of a scheduling tool and actually real-time live IPMVP tracking of projects. So now let's dive into the next two steps. How can we, from these detections, from these, after those free wins, how can we now go to actually structurally planning, tweaking your optimal investment plan, and also executing it and making sure they deliver? So from here, this is a project planner, and this is key. In this case, it's on a building or facility, but you can do this on a site, you can do this on a portfolio. And the whole idea is that actually you plan all different things you want to execute in time, and you can see immediately the impact on, for example, energy consumption, but also on connection capacity. You can do the same on CO2 emissions, you can do the same on other drivers that are important for you for energy management. So the key is here on the timeline, we have the already suggested pre-selected projects. You can pull in other projects. And with this, you can actually see, hey, if we don't do anything, given on extension of our site, we follow the gray line. But if we actually do improve, we will follow the different lines. If we execute everything that's scheduled here with these investment costs, then we will actually follow the purple line. But if we implement all the suggested projects, we will be on the black one. And this way you can actually live build and continuously update an optimal plan towards lowering energy consumptions, but also towards, for example, grid capacity. This can also be towards energy cost in global and not just consumption. In this case, you see, for example, the red line being the grid connection that actually ups in 2027 in order to increase. But you can also actually see how this evolves over time if we don't do anything, or we'll have a big problem, or if we execute these projects and what the impact is. Good. We'll jump to the next one. In the meantime, some of you maybe already seen it, but I published a small poll, which will be live for 1 more minute, where I actually ask what are for you the top 2 drivers. You can select 1 or 2 in energy management. What for you are the ones you would manage towards? It would be interesting to know that for this audience. Let me jump to the next slide. In the meantime, just a second. Here we go. So now let's dive into. That's always the risk if you do it live. Here we go. Sorry, because I was sharing the video, it didn't want to jump slides. As a last component, and then we'll go into a use case to show what kind of impact this can have. A quick vision item. What I've shown so far are things that are possible today and tomorrow. Things that can, if you implement those, are feasible to do on your data within this and the end of the year, if you want. This is things where the next few years will go towards. And a big thing, and it's a big hype in the AI world at this today, is agentic AI. And what it actually means is it is not so much the intelligence that is so new, but it is linking the intelligence that is possible today with AI with actual execution, linking this to real systems that actually can take real actions. What is key in this is that you can still control this, master this, and the energy manager is, in a sense, the master of puppets here, controlling the small agents. But you can extend your team, your capacity with this type of functionality. And some examples of things that will become possible here is, for example, the real-time monitorings across buildings, fleets, equipment to auto-schedule interventions. It doesn't mean that it will intervene itself, but it can deploy and schedule these things controlled by you towards the right people, the right maintenance technicians, the right parties. Also, and a very interesting one is gamifying energy efficiency. As you know, how people act in your organization has a big impact. If people turn systems on or off, actually change the way they behave in an asset, and they don't know how much impact it has on the energy consumption, if you, every time you detect something like that, can send a personalized nudge from, hey, what you just did, turning the HVAC control off, hey, this is costing you the equivalent of 4 employees in salary. Like, you can give very personalized trainings and feedbacks in a human voice, and that can have a lot of impact on efficiency just by targeting those people. The same is possible with automating live dashboard, making actually you ask for a certain dashboard and it will generate that for you. Same with continuous energy automation, energy audit, which is already, so I showed you some of the possibilities there already, but that it becomes a dynamic action planner where it helps you towards your optimal setting that you selected as really literally AI sidekick for you. This is where AI will be going the next few years based on these stacks. But the key one here still remains having the AI that can analyze your energy consumption data. And that is a big gap in most cases, in most applications where they just try to slap on generative AI on traditional energy monitoring systems. So very briefly, a use case. This is a use case anonymized, but on an actual customers of ours that actually was doing a great job already in energy efficiency, energy costs, but also CO2 emissions. The multi-site, semi-industrial, some commercial buildings, but also like a lot of specific activities in those. And they reduced a lot already in energy consumption. Thing is that they were kind of plateauing with traditional approach. So that is when we started using AI. And that here you see the inflection point in a sense. They are already at a 74% reduction compared to 2024. And their goal on energy consumption is still to go a lot lower, on CO2 emissions to literally go to a net or even absolute zero in their case, given their definition of this. That with a team of 2 to 3 people in energy and sustainability. And actually, in this case, the hidden cost of complexity for their case is also not only how can you reduce the energy cost, but how can you reduce the amount of investments needed for that? You will need investments. That's not the point. But if you can put those operational wins in place, prioritize the better projects with higher yields, and actually ensure by tracking every project automatically and compensating that for external variables, you can increase your project yield with 32%. They could reach this with 51% less CapEx investments than anticipated. And this is the kind of impact you can generate if you use it on all the steps, which of course is AI will help you a lot, but it's still the job to be done. But the combined force of the two can scale the power of it by a lot. Some key takeaways of today. The most important one, we think, or at least the first one, the fastest result, is that AI can guide you to the complexity. It can help you see what is possible where and help you prioritize those so you can make informed choices. Generate a lot of quick wins. Yes, the big investments are needed. Yes, the plans are needed. Yes, getting structural reductions with bigger measures are needed. But there's still a lot to win quickly. And that's unfortunately today often ignored because that means a lot of interactions with facility management teams, with maintenance teams, and that's just cumbersome and impossible if you're on your own or with a small team. But if you have an AI doing that for you and you can orchestrate the AI, it's a different story. And then actually executing a PDCA cycle correctly, really planning continuously live, checking and seeing where it brings you and feeding that back continuously with planning tools as shown, with checking tools I didn't show here, but would love to show you if you're interested. where you can get a lot faster in iterating and booking real results without it becoming a paper exercise. And that all in direct sync with facility managers, executives, and sustainability managers. This is what AI can do today and tomorrow. If you have some additional questions, we have foreseen 10 minutes for Q&A. Feel free to post them in the chat, and we will address those right away. Just opened the Q&A as well. So here you can, not only in the chat, but in the Q&A, ask some specific questions. In the meantime, what software we did use to show these results? You mean that's a question of Emilio. Well, what I've shown you so far is that is actually the NRC platform we have shown you at this moment. That's our front end. Of course, some of these things can be done if you build a lot of AI tooling around it. We explained how it's done, but we automated the workflows around it. That is what we've used. Any other questions? In the meantime, I'm going to look at the Q&A, the interaction one, sorry, the poll. So for the most of you, 11 people voted for, I'm going to show them right now. 11 voted for energy cost reduction. And this is a classic one and a logical one. It's still the most important ones. A lot of people are focusing on CO2 emissions and regulatory compliance, 7 each. And then we have 4 that focus on energy supply and avoiding net congestion. I'm assuming that are maybe more the industrial players in the room that are focused on that or that have business risks in expanding certain sites. We've seen all 3 of them in our customer base. Each one is important, of course. But it would be interesting to, if you have questions on your specific driver, where you would want some more information, feel free to post those, and we would love to get in touch with you on those. Going to take a look in the meantime at the chat or Q&A. Just a second, someone. Good. A question of Emilio on the business model in NRC. Of course you can. Very briefly on that. I immediately got another question. So first of all, on the business model, a question of Emilio. Yes, you can. We have 2 general models. We have a pay-per-building model and a model where we have a portfolio price. What it actually means is that we have a standard version and a plus version in our software. The plus is includes everything. The standard still includes more than any traditional energy monitoring software. And there is a monthly fee per building, per site, per facility. That's the way it works. In the portfolio packs, actually the price is per 100 locations or facilities. And then there is some economies of scale in that. So it's simply a monthly fee. That's a conscious reason why we do that. Because then we can help you track all projects. We can help you generate those savings. And if we would be billing you based on the savings, we would be kind of the, how do you say, in Dutch we say you're both you're both trying to execute it and you're trying to be the referee, and that is a conflict of interest. What would be the key difference between your model and just training your own custom GPT with ChatGPT Plus, for example, in terms of analyzing data of the model itself, not dashboarding per se? Good question, Thomas. Very simple, and that actually comes back to one of the slides I've shown in the beginning, is that, yes, of course, the way we dashboard it and the workflows around it are important, but also, and that is actually where we focus the most of our time on, is a time series AI we've built. And that actually is an AI that analyzes all the energy consumption streams, automatically models every installation, main buildings, main assets from production to commercial buildings, sub-installation, and actually models every time of energetic behavior in time. A ChatGPT, like a ChatGPT Plus, cannot do that. They're good at language, they're good at interpreting text and images, but they're very incapable of analyzing time series quantitative data. So we actually built that ourselves, spent 4 years of R&D with a full team on that. And that actually builds the questions, builds the insights, builds the anomalies. And these are then asked to an AI, an optimized and trained version like a ChatGPT Plus. But without that first part, it gives you bullshit answers, to put it simply. And that is a key difference. I see there is a question in Q&A, but somehow the webinar tool doesn't show it to me. I'm going to take a look if I can find the question there. If I didn't answer your question yet and you posted it in Q&A, please repost it in chat, because somehow it doesn't want to show it to me. I see one in. Yes, now one of my team members posted it to me, the Q&A question. Which sector are the most quick wins to be achieved? Well, really good question. That actually depends more on the company than on the sector, I would say. We have a lot of like the big retail customers, and we see a big difference between certain retailers that are like very optimal already. We still yield great ROI on the software there, but actually are already very efficient, and others where on day one you have huge wins. But we see the same in hospitals, we see the same in large buildings and in industry. Very often, it's the more complex the assets, the more the quick wins are. Often people think it's easy to win a lot on an old, simple building. Yes, you can, but actually it's very often in complex buildings with a lot of automation, where there's processes already. It can be logistic buildings or buildings with a lot of cooling, or it can be semi-production instances like pharmaceutical buildings. These often have a lot of inefficiencies because the management of the automations is not optimal. And there we have a lot of quick wins to realize in those cases, if that makes sense. We've got 1 more minute. I don't know if there's a last question that pops up. And otherwise, feel free to, going from Wim, I see, and that question. Feel free to reach out to us later on. I would love to answer additional questions if you have any. Also, as a last thing, this was the first time we did a webinar. We're planning on doing more. If you have any feedback on the format, on the content, feel free to post it. We want it to be as valuable as possible for you. So I hope it already was, but even if it was not, please send us a feedback. We want to learn from our audience as much as possible. Thanks a lot for your attention, and hope to see you soon. Thank you, Johan, for your feedback already. Good. I will close it in a few seconds. Thanks a lot, everyone, and see you soon. Bye-bye.